So now we're on 3.1, page 4. What we want to look at now is a real-world example on what you would do with slopes of tangent lines or with derivatives. This graph represents the level of water in the canal near Mrs. Rachel's parents' house in Florida, and the level of water in the canal varies according to the tide in the Gulf of Mexico. And this graph shows the depth of the canal over a 48-hour time period. So we can see that the depth here, we got 8 feet here, 6 feet will be about here. There's not a line for it. We have to imagine. Here's all the times a day, starting at 3 p.m., midnight, noon, and so forth. Okay? So we can see, and it makes sense, that the water level increases and decreases. It rises and falls. So on that graph, if the y value here represents depth of water, when would high tide be? Well, that's going to be where the tops are here, where the maximum height is. So we got a high tide up here, and we have another one here. So in this 48-hour period, there was 2 high tides. We'll just estimate when it is. This is about 9 a.m. on the first day. This one is about at 11 a.m. on the second day. Just roughly. Okay, how about low tide? When is low tide? Well, low tide is going to be the low side of this. So where the y value is the smallest in these places. So low tide, I would say is going to be about there, say 5 p.m. on the first day. And then the next lowest place, which kind of mimics the first one, is here. That looks like about 6:30 p.m. on the next day. Okay? So if you notice, the high tide and the low tide, the highest spots and the lowest spots, those are like the maximum values and the minimum values. And they're changing from a point for the maximum. It's, the water's getting deeper and deeper, and then it's getting less deep, so it's a maximum of the height of the water here. Likewise for low tide, the water's getting more and more shallow until it gets to its smallest or shallow point, and then it starts getting deeper again. So your next question is, at what time does the water level increase at the fastest rate? What time does the water level increase at the fastest rate? So the rate of change on a secant line or the rate of change on a tangent line is just simply the slope. So we want to know, where do we have the biggest slope, the fastest rate of change? So we're just going to estimate here, but if we've looked at various places where we have increasing values here, we could just sketch some tangents, and we could see where we think we have the steepest slope. And I'm going to come up here. I just want a tangent at a particular point there. None of these look very similar. Actually, this slope is a little smaller than the last one. So I'm going to go with this one. It has the largest slope. So at the fastest rate, I'm going to say it's kind of hard to see where exactly it matches, where it fits onto the graph. I'm just going to estimate here. I'm going to say between 8 and 11 p.m. on this day. Okay? Between 8 p.m. and 11 p.m. on the second day. It doesn't have to be perfect here. We're just estimating from this graph. It actually wants to know here, it's asking us, what is that rate of change? So basically I need the slope of the tangent line here. I need the slope of this line. So I could take a point right here. Let's see, that point would be 2 a.m. and 8 feet. And I'll compare that to another point here on the tangent line. We'll go here. Let's call this one 8 p.m. And we'll call that one, I'm going to call it 6 feet. No, it's not exactly that, but it'll give us something to go with. Okay? So, in order to get the slope of that, I basically just need an average rate of change. So I'm going to use the change in the y values. We're going to go from 8 feet or 6 feet to 8 feet. So there's my change in y values, change in depth. Change in time, I'm going from 2 a.m. To 8 p.m. or the other way around, 8 p.m. to 2 a.m. So I got 2 feet in height, and this would be 6 hours in time. So my increase is 1/3 feet per 1/3 foot rise, let's be specific, per hour. So that's our rate of change there. Next question, does there appear to be a time when the rate of change in the water level is 0? I'm going to fold my paper here so I can get everything on the screen at once. What time does the rate of change appear to be 0? A rate of change of 0 would just be a horizontal line. In our case, we're looking for horizontal tangents. So actually at low tide there's a horizontal tangent. Here's another space in between here. It seems like there's a 2-hour time period with a rate of change of 0. High tide has a tangent line of 0. There's another low tide with a tangent of 0. Here's another extended portion that looks like it has a slope of 0. And then high tide. So high tide and low tide points are places where the rate of change in the water level is 0, but it's just momentarily, right, at those horizontal tangents. Let's focus on these times where it seems like the water level is just sitting at a fixed spot for 2 hours. So what times are those? Let's say from midnight to 2 a.m. on the first day, and the second one would be here, that's 2 a.m. to about 4 a.m. on the second day, where there's no movement at all. Those are actually, there's a name for that. It's called slack tide. Okay, the next question. At what times is the rate of change in the depth of the water positive, and what times is it negative? A rate of change in the depth that's positive means increasing. When is the water increasing? If the rate of change is negative, it is decreasing. So we'll just list the times, positive or increasing, and we can think about what our breakpoints are going to be here in the graph. So the first place where we start being positive is this 5 p.m. I'm going to say 5 p.m. to all the way up to midnight. That's my first one. Then I have my slack time, so I'm going to skip that. But then it continues to increase. I'm going to say 2 a.m. to 9 a.m. Then we're going to have a part that I'm decreasing, so I'll skip that. And increasing again here from 6:30 p.m. up to about 2 a.m. and then increasing again from 4 a.m. up to 11 a.m. The places where I'm decreasing is right at the start of the graph, actually 3 p.m. to 5 p.m. It's not decreasing here, it's steady, so we'll skip that. The next decreasing starts there at 9 a.m. up until 6:30, and then it's decreasing at the end, 11 a.m. to, looks like about 2 or 3 p.m. So it's either going to be positive and increasing, or negative and decreasing, or it's going to be this slack time.